Good morning. We're going to begin a new unit. This is Unit 7, Domain 7, about astronomy, called Our Solar System and Beyond. And we'll start out, of course, talking about our Earth. But before we do that, we have some things that we need to talk about as far as background knowledge. When you go out during the day and you look up into the sky, what do you see? Well, you're going to see the sun, clouds. You might even see the moon, which we think about mostly seeing at night, but it's there. So when we look up into the sky and past the clouds, you're really looking into outer space. Over the next few weeks, we're going to be learning about outer space, and the study of outer space is called astronomy. Astro is part of that word, means star. So astronomy includes the study of the stars. Astronomy also includes the study of all objects in space. Sometimes these are referred to as heavenly or celestial bodies, which is just a fancy way of saying natural objects in the sky. If astronomy is the study of the stars and other objects in outer space, what do you think a person who studies astronomy is called? You're right. Astronomers. Those are the scientists who study all of the objects in outer space. That most of what we know about in outer space, we have learned from the observations, measurements, and thinking of astronomers. Now, Earth is located in space, but when we use the term outer space, we are referring to areas that are beyond Earth's immediate atmosphere. So, if you think about things that are in our sky, such as airplanes and birds or clouds, those objects are located inside Earth's atmosphere and they are not considered to be outer space. So we're going to be talking about solar items. When you'll hear this word a lot in our domain, and sol, S-O-L, is Latin for the sun, so solar means related to the sun. Can you think of any phrases that include the word solar? We talk about solar system and solar eclipses. We're also going to be hearing the word lunar. Lunar relates to the moon. So those will be important vocabulary that we will need to remember. We learned about atmosphere way back when we talked about classic tales, The Wind in the Willows. Do you remember what the definition of atmosphere we learned in that domain? It was the distinct quality of a place. We heard about the atmosphere in The Wind in the Willows as it referred to how a place felt or seemed. Remember, the water rat felt uncomfortable in the underground atmosphere, unlike Mole, because it was very enclosed. He preferred an atmosphere that was more open and free, like the riverbank. Well, that's one way to use that word atmosphere, but it also has a different meaning. And when we talk about it in a scientific setting, we really are talking about something different. The nearly invisible blanket of air or gas that surrounds Earth and other bodies in outer space. That's the type of atmosphere we're talking about here. So if you think about a globe, and the globe doesn't show the atmosphere surrounding Earth. A gas is a very thin substance that objects can pass through, like air, smoke, or steam. And our location here on Earth, it's hard to see the atmosphere, but from the distance of space, there is a very thin layer of atmosphere that becomes visible. You also heard about atmosphere in the light and sound domain. We learned that light energy from the sun must travel through Earth's atmosphere to reach us on Earth. And some sunlight is absorbed by the atmosphere, and some of it is diffused or scattered by the particles in the atmosphere, so it does not reach the Earth. So The word atmosphere in the wind and the willow refers to how a place feels, and the word atmosphere in astronomy refers to the area of gas surrounding Earth or another planet. Atmosphere is an example of one word that has multiple meanings depending on how it's being used. So as we read today's Read Aloud, think about and try to predict if you needed to give someone an envelope that was addressed to your school address using a space address, what might be on that envelope? So our planet Earth. If you traveled to another country and someone asked, "Where in the world is your school located?" you might answer by giving the school's address. Its address explains where your school is located on planet Earth. It might be our school's name, our school's number and street, our town or city, our state and zip code, and our country. And a mail carrier would be able to find our school and deliver this envelope from anywhere in the world. But let's pretend that you traveled far, far away to a distant place in outer space, and an extraterrestrial being asked you, "Where in the universe is your school located?" How would you answer that question? You would need to give someone who lives far away from Earth more information as part of your school's address, a space address that explains where your school is located on a map of the universe. The first part of your space address that you would add to the envelope is your planet, Earth. You might think you already know everything there is to know about Earth. After all, you've lived here your whole life. But what do we really know when we say we live on a planet? The word planet means wanderer. It's a name that the ancient Romans gave to objects in the sky that appear to wander on a different path than the stars did. As astronomers have continued to observe and study space with more powerful tools and learn more, they keep thinking about and discussing the exact definition of a planet. Scientists today classify a planet as having 5 important qualities. 1, a planet is a sphere or nearly round object in space that has a large mass. 2, a planet travels or wanders in a path called an orbit around a star. 3, a planet has cleared out most other objects from its path as it orbits around the sun. 4, a planet is mostly made of rock or gas or a combination of both. 5, a planet does not make its own light, but shines in the sky because it reflects the light of the star that it orbits. Planet Earth is made of rock and orbits a star that you already know by name. What is our star? The Earth's star is the sun. The sun, like all stars, is an enormous mass of incredibly hot gas. It creates a huge amount of energy in the form of light and heat. Earth is one of 8 planets that orbit the sun. Actually, Earth is the 3rd planet away from the sun, 93 million miles away to be exact. That's a long way. If you drove from Earth to the sun in a car going 60 miles an hour, or the speed you might travel on a highway, it would take you almost 177 years to get there, and that's without stopping to stretch. Most living things on Earth need heat and light from the sun to survive. 93 million miles may seem far from the sun, but it's actually the perfect distance for human, animal, and plant life on Earth to exist. You can think of sun's energy as being like the temperature of Goldilocks' porridge. If the sun were closer to Earth, it would be too hot, so hot that Earth's water would boil away. If the sun were farther away, it would be too cold, so cold that Earth's water would freeze completely. As it is, Earth's position in our planetary system is just right for life. In fact, Earth is the only place in our solar system of planets, or really in the entire universe that we know so far, where we know life exists. So we can survive because Earth is exactly in the right place in our solar system. Another reason life can exist on Earth is because of Earth's atmosphere. An atmosphere is a covering or envelope of gases that surrounds a planet. Earth's atmosphere traps the sun's heat, keeping it near the surface of Earth. This keeps Earth from getting too cold. Earth's atmosphere is all around us. Take a deep breath in and hold it. Well, you have just breathed in some of the atmosphere. Now breathe out. Your breath has just added something to the atmosphere. Besides providing the air we breathe, the atmosphere also protects Earth. So the atmosphere does two things. It provides the air we breathe, and it protects the Earth. Have you ever slathered on sunscreen to keep from getting sunburned when you go outside? Well, the Earth's atmosphere is like sunscreen for Earth, blocking some of the sun's harmful light rays from reaching Earth's surface. Earth's atmosphere also diffuses or scatters some of the sun's light. This is what makes the sky look blue. In images of Earth, as seen from space, it's easy to see the blue of Earth's oceans. Water covers about 70% of planet Earth. That's a lot more than half of the surface of the Earth. Earth's water is essential to support plant and animal life as we know it. One moon orbits Earth many miles beyond Earth's atmosphere. Earth's moon is by far our closest neighbor in space, but it's still far away. Do you remember that classical Mother Goose rhyme? Hey diddle diddle, the cat in the fiddle, the cow jumped over the moon. The little dog laughed to see such sport, and the dish ran away with the spoon. Well, that was one high jumping cow. The moon is about 239,000 miles away from the Earth. So if a cow jumped from Earth to the moon going 60 miles an hour, it would get there in about 166 days. That would be one mighty jump for a cow. At that same speed, you remember how long it would take to get to the sun? 177 years. Whoa. You have seen the different phases of the moon as it changes shape during a month's time. As the moon orbits Earth, we see different amounts of sunlight reflected from the moon's surface. Sometimes the moon, Earth, and sun line up so that one of them is hidden from view. This is known as an eclipse. A solar eclipse happens when the moon comes between the sun and the Earth, hiding the sun so some people on Earth can't see it. A lunar eclipse is when Earth comes between the sun and the moon. When this happens, people on Earth see Earth's shadow on the moon, making it appear dark or sometimes even to disappear. But the moon doesn't really disappear. It's just hidden for a short time in Earth's shadow. So pretend you're standing on Earth. This is the moon. The moon, this dark part is the shadow. So people standing right here on Earth would not be able to see the sun. A couple of years ago, there really was a solar eclipse that a lot of people in the United States got to see, which is very unusual. I got to see that one. It was phenomenal. Pretend again that you're standing on Earth. That's your home. That's the only place you've ever been. But now you're standing over here and you're looking at the moon, and you can see that here's the sun, the earth is creating a shadow, and the moon is in the shadow of the earth. This happens a lot more often, and because the earth is larger, we get to see lunar eclipses more often. Here we're not going to be able to see the moon very well. It's in the earth's shadow. Planet Earth moves in two ways. The first we've already talked about. It travels in a nearly circular path or orbit around the sun. So that's the first way that planet Earth moves. It orbits around the sun. The actual path of Earth's orbit is not a perfect circle. It's just a little longer in one direction than the other. And the name for this type of circular path is called an ellipse. It's an oval. An orbit that is shaped like an ellipse is described as an elliptical orbit. It takes Earth 365 and 1/4 days to orbit the sun one time. So Earth's year is 365 days. The amount of time it takes a planet to orbit the sun is called its planetary year. But what about that extra 1/4 day? Why don't we count it? Well, actually, we do count it. We just don't count it every year. Instead, we add up the extra 1/4 day for 4 years in a row to make it one full day. So we have 1/4, we've got unit fractions. 1/4 plus 1/4 plus 1/4 plus 1/4 is 4/4. And you know that 4/4 equals one whole. So every 4 years, we add one full day to our calendar. We do that at the end of February so that it has 29 days instead of its usual 28. And we call this year with an extra day a leap year because everything leaps ahead by one day. So every year, like starting right here, this is where Earth is in space. If this is your birthday, you will not have another birthday until Earth goes around the sun and ends up in this place in space again next year, and it will be your birthday. My birthday's somewhere over here in space. It's in December. So I've already gone almost a quarter of the way around. The second way planets in our solar system move is by spinning as they orbit the sun. Have you ever spread your arms wide and twirled yourself around until you're so dizzy you could hardly stand up? Can you feel the axis or center line of your body around which you spin? What parts of your body rotate or spin around your axis? Maybe you have played with a spinning top or have seen an ice skater spin quickly around and around on one foot. This is what it means to rotate. To rotate is the second way that Earth moves. Planet Earth orbits around the sun and rotates on an axis. When a planet rotates, it doesn't twirl around on feet like you do. It spins around on an imaginary line that goes from its north pole to its south pole, right through the center. The imaginary line is called the planet's axis. One day is the amount of time it takes for a planet to rotate one time around its axis. A day on Earth is 24 hours. These 24 hours are divided evenly into daytime and nighttime. As Earth rotates, half of the Earth faces the sun and receives the sun's light. So here's the axis. It's an imaginary line. And here is the half of the Earth, which is in daytime, and the Earth is spinning this direction. Earth faces the sun and receives the sunlight during daytime. It is daytime on this side of Earth. But at the same moment, the opposite half of Earth is facing away from the sun. This side of Earth is not receiving any of the sun's light. So it's dark there. It is in Earth's shadow. It is nighttime. We don't feel Earth spinning. From our viewpoint, it looks like the sun is moving and the Earth is not. After all, doesn't the sun appear to rise every morning in the east and set every evening in the west? This daily motion of the sun from east to west might make it seem like the sun is moving around the Earth, but it's not. You are moving around the sun, or really, Earth is. In the morning, the part of Earth that you are standing on is turning away from the darkness and rotating to face the sun. When the sun is up at its highest point in the sky, Earth has rotated so that you are fully facing the sun. In the evening, Earth turns away from the sun and it becomes dark again. Why is it dark? Because you are in the shadow of Earth. It is night and you go to bed. But as you sleep, Earth keeps rotating on its axis, and before you know it, your side of the world will have turned to face the sun again. You and the part of the Earth on which you live will have once again moved out of Earth's shadow, and you'll know that one rotation of Earth one day will have ended, and another is just beginning. Days turn into months, and months turn into seasons. What are your favorite seasons of the year? Fall, winter, spring, summer? You might know what your favorite season is, but do you know what causes the seasons? It's the combination of the two motions of Earth that we've been talking about. The combination of Earth's orbit around the sun and Earth's rotation on its tilted axis. Remember, an axis is the imaginary line that goes through the center of a planet from its north pole to its south pole, and then points out into space in both directions because it's a line. But a planet's axis doesn't always point straight up and down like the axis of a spinning top. Many planets, including Earth, have an axis that is tilted a little to one side. This tilt is the key to understanding Earth's seasons. So these are two different pictures, and they show the same tilt of the Earth as it's going around the sun. And we just had to condense this picture, take all this space out of space, and say this is how the Earth would tilt toward the sun one season, and this is how the Earth would tilt away from the sun during another season. Because Earth is tilted, there is a time of year during Earth's orbit around the sun that the North Pole and the whole northern hemisphere is tilted a little bit toward the sun. This tilt gives the northern hemisphere longer periods of daylight, shorter periods of nighttime darkness. Longer periods of daylight give the sun more time to warm the Earth so it gets hotter. The tilt of Earth's axis also makes the sun in the northern hemisphere appear higher in the sky at noon. When the sun is higher in the sky, its rays hit Earth more directly, at less of an angle. The more directly the sun hits the northern hemisphere, the better job it does of heating that part of Earth. So, it is the tilt of Earth which causes longer periods of daylight and a high noontime sun that makes summer happen. So in the northern hemisphere, because the axis is tilting toward the sun, in the northern hemisphere, this is summer. At the same time, the southern hemisphere is tilted away from the sun, and the southern hemisphere is having winter. Now the Earth travels half of a year to get to this portion, and the Earth looks as though it's tilted, the northern hemisphere anyway, is tilted away from the sun. The southern hemisphere is tilted toward the sun. These would be the opposite seasons. Less direct sun rays, farther away, this would be winter. Well, it's summer in the northern hemisphere. Let's see what's happening in the southern hemisphere. Why is it winter on this part of Earth? The reason, again, the tilt of the Earth. When the northern hemisphere, it's tilted toward the sun. The southern hemisphere is tilted away from the sun. This causes the southern hemisphere to have shorter periods of daylight and the sun to appear lower in the sky at noon. Shorter periods of daylight give the sun less time to warm Earth, so it's cooler. And when the sun is lower in the sky, the rays hit Earth at more of an angle or a slant. This angle makes the sun have to heat a larger area of Earth with the same amount of energy, and it means the sun does not feel as warm. The rays of sunlight are less direct and less intense. It is colder. It is winter. As sun continues its orbit around the Earth continues its orbit around the sun, Earth continues orbit, the axis of Earth always stays pointed in the same direction. So when Earth reaches the opposite side of the sun, half a year later, South Pole instead of the North Pole is now tilted toward the sun. It means that the southern hemisphere has summer and the northern hemisphere has winter. The seasons in the northern and southern hemisphere are always opposite each other. That's because one of them at a time is tilted toward the sun. So now you know the first part of your space address. Your school is on planet Earth, and planet Earth is part of your space address. So now you have more information that you need to answer an extraterrestrial being that might ask you where your school is located in the universe. So you have your school's name, our school's number and street address, our town and city, our state and zip code, our country, and you have our planet, planet Earth. In the next lesson, you're going to learn more about the next line of your space address. But let's answer some questions first. What kind of space object is our sun? Our sun is a star. And why is the sun classified this way? Because it's a huge distance mass of fiery gas that gives off constant light and heat. That's what a star is. What kind of space object is Earth? It's a planet. Why is Earth classified this way? Earth is a sphere. Remember those 5 different qualifications of a planet? Number 1, Earth is a sphere or a nearly round object in space that has a large mass. 2, Earth travels around in a path called an orbit around our star, which is called the sun. Earth has cleared out most other space objects from its path as it orbits around the sun, although it has captured the moon. 4, a planet is mostly made of rock or gas or a combination of both. Ours is a rocky planet. And Earth does not make its own light, but it does shine in the sky because it reflects our sunlight. Describe the ways in which Earth moves in space. Earth moves 2 different ways. Earth orbits the sun in an elliptical orbit, and Earth rotates or spins on its tilted axis. What characteristics of Earth did you hear about in this read aloud that make Earth a good place for life? Well, Earth is the 3rd planet from our sun, and it gets just the right amount of heat and light. Earth is just the right temperature. It has an atmosphere that protects life from harmful sunlight, and it helps hold the heat in to maintain a steady temperature, and it has water. So it has just the right amount of heat and light, just the right temperature. Atmosphere protects life, holds in heat, and it has water. So can you remember what a solar eclipse is and what happens during a solar eclipse? Sunlight is blocked from Earth because the moon gets in the direct path between the sun and the Earth. This is a solar eclipse. You always look at an eclipse from the perspective of Earth. So if you were standing here, the moon has gotten in your way and you cannot see the sun. Here, the Earth has gotten in the way of the sun, sunlight trying to hit the moon. So this is a lunar eclipse. Just always remember that you're standing on Earth. And so an eclipse is described from the perspective of Earth. How does the rotation of Earth cause daylight and darkness? Well, there is a constant rotation of Earth, and it changes the part of the Earth that is facing the sun and receiving its light. When a portion of Earth is facing the sun, it experiences daylight. When a portion of the Earth is facing away from the sun, it is in the shadow of the Earth itself that is darkness and nighttime. So why does it seem like the sun rises and sets then? Well, the sun appears to rise and set because Earth is spinning on its axis as it orbits around the sun. And the sun appears to rise in the east, and the sun appears to set in the west. So, what causes the Earth to have seasons as it orbits the sun? Well, the Earth is tilted in a fixed position on its axis, and it travels around the sun. One side or hemisphere is always tilted toward the sun. The other hemisphere is tilted away from the sun. The hemisphere that tilts toward the sun gets more direct sunlight and experiences summer. The hemisphere that is tilted away on this side, once it travels around the sun for another half a year, our hemisphere is tilted away from the sun. It gets less direct sunlight and experiences winter. So imagine that you're traveling through the universe and you meet an imaginary extraterrestrial life form that asks you where your school is located. Describe the part of your space address that would be important to share. Well, it would be important to share your school's location, the name of the closest town or city, your state, your country, and planet Earth. All right, there will be more later, but this was a very full lesson. See you tomorrow.